Hello, happy April Math 10 students. We are starting chapter 7 today, our last chapter in this book, so way to go. Thanks for passing your tests in. I will be correcting those very shortly. And as I did state, you were able to use your book, and that's how I'll be going forward with this last chapter as well, okay, for your tests. So, chapter 7 in your book, you're roughly page 394. What I recommend, now that you're doing this online with me, you're doing some work on your own, read through the chapter yourself and then watch these videos. And when you're watching the videos, feel free to pause, stop, fast forward. If it's too slow for you, you can actually, in YouTube, you can go in like a little faster mode so you don't have to be like bored. Anyway, so for today, I'm just going to tell you a couple key things about this chapter, a couple definitions. We already know that a linear equation looks something like this. This is just an example. Y equals 2x plus b, or that's in the y equals mx plus b form, or our slope-intercept form, you can see there. Okay, so I think that's actually a 6. Whatever, that's an example of a linear equation. Now we're going to be talking in this chapter about systems of linear equations, or linear systems. Okay, the only difference of what this is, it's when you have two linear equations. That's what we're going to be doing in this. Two linear equations. When you put them together, it's now called a linear system. Okay? And for example, if we were going to draw our two linear equations, I won't do these ones exactly, but just say it was something like this. Okay? You can see they have a point of intersection. That leads me to my next point I want to tell you about. The solution or answer of linear systems is the pair of values, or the coordinate, that satisfy or work in both the linear equations. So for example, back in this example, there's one point right there. Let's say it's -3, 3, I don't know. That particular point, that x and y value, would work in both of these equations. Now I just made this up, but if it was these two equations, there would be an x and a y value that if you plugged it in here, the x and the y, the left would equal the right. If you plugged in the x and the y here, the left would also equal the right. So it's actually super fun and really neat, and it's one of these things that I really like because you can always know if you're right or wrong. You can always check your work by going back and plugging it in. Okay, so that's just to set us up, and you can look in your book on page 396 if you want to read a little bit more about those definitions, but that's what we work with, linear systems. Okay, so I'm just going to erase this, and we're going to go over some of the check your understandings. How's everybody doing? What's new? Are you excited that it's April? So as you know, we're going to be online till at least May 1st now. So I hope you're all kind of getting used to it and getting used to Google Classrooms. And again, if you ever have any questions, email me. I'm happy to do video one-on-ones or a group, whatever works for you. Or I can snap a picture of any of the work that I've done as well for you to look at. So last week, Beth and I had a great one-on-one, and we went over a bunch of questions. The whole class was invited, in fact. So take advantage of those things. I'd love to see you. Don't be shy in that regard. So let's go to page 397, and we're going to do the check your understanding. Again, I recommend you read through the example yourself. Okay? The check your understanding says, create a linear system to model this situation. The stage at the Lyle Victor Alberta Centre in Bonnyville, Alberta is rectangular. All right, I'm just going to draw a rectangle. They've told me some information. It's a stage, it's rectangular. Great. Its perimeter is 158 feet, okay? The width of the stage, W, is 31 feet less than the length. Okay, so we'll get back to that, but we know the width is 31 less. All right. So all this has asked us to do is model this situation. So let's start with our diagram. Let's do these are length, it doesn't really matter, these are width, okay? So this is our stage, and the information that we've been given, if we were going to find perimeter of a rectangle, what is it? How would we find perimeter? Yes, Hannah. That's right, we add up all the sides, so L, let's say L plus W plus L plus W. This would be our perimeter. okay? Or you could say this. See how there's L plus L would be 2L, W plus W would be 2W, okay? So our perimeter would be something like this, and they've actually given us what the perimeter is. So let's go ahead and put that in. I'll just put that over here. So 2L plus 2W equals 158, okay? So if we knew what the length was, and we knew what the width was, we could put them in there, and it would equal 158. And right now, with that information, there's a lot of different combinations that could work here. But there is only going to be one correct solution. So let's look at that second part that they told us. They said the width of the stage is 31 feet less than the length. So from that, if I took my length and I subtracted the width, what did they say? What was the difference? How much less was it? They told me it was 31 feet. So let's write that 31 in, okay? So if I had the length and width, and I put in, because it told me that the width is 31 feet less than the length, so the length minus the width is 31. So now, what I've done here is I've created a system, a linear system. I have a system of equations, okay? So let's just check with the book. I noticed the book has, the second one looks a little different. It says width equals length minus 31, okay? That is fine. This would also be correct. This is still an equation. If I wanted to change this around a little bit more, I could do that different ways. I'll show you, okay? So I could say that my length is also equal to 31 plus the width. You see that? Length, if I took the width, if I added it on both sides. If I wanted to have it just isolate W, it would be length minus 31, wouldn't it? If I took the 31 over here, length minus 31 would be my width. And that's how the book has it. But again, any of these would all be correct ways to represent that same equation. Okay? So there we have our system of linear equations. Then it says, Sebi has determined that the stage is 55 feet long. Okay? So the length is 55 feet. This is what Sebi found out. And 24 feet wide. Okay, he found that out. Now, in this one, we're not actually going to solve this linear system. We will get into that, but for this one, he's telling us Sebi did the work for us. Okay, use the linear system from part A to verify that Sebi is correct. Okay, so I'm going to leave that on the board there for us. I'm going to erase over here. Okay, so in order to verify that Sebi is indeed correct, what we're going to do is we're going to use both of our linear equations, and we're going to use this information that's been given. And if he's correct, or she, the left side will equal the right side in both of our linear equations. So let's start with the first one. 2L plus 2W equals 158. All right, so if our L, 55, we're going to put that in for L. Our width, 24, let's put that in for W, 158. So again, I'm hoping that the left side equals the right side and that these numbers are true and accurate, that this could work. So 2 times 55, 110. 2 times 24, 48. Is 110 plus 48 158? Oh, yes, indeed. So my left side does equal my right side. So far, so good. Now, even though these worked in this one linear equation, that doesn't mean yet that he's right. It has to work in the second one as well. All right? So let's try our second one. I'm going to erase that, but again, pause this at any time if you need it. Okay. And I'm just going to use the form that I did originally, but again, you could use any of these forms. So L minus W needs to equal 31. Okay. My length was 55. My width was 24. Okay. 55 minus 24, 31. Woohoo! Happy day! 31 does equal 31. So, Sebi is right. These numbers, 55 and 24, are correct. Okay? So, if you went back and, just like I said, this is 55, this is 24. Okay? And the length minus the width, it is 31. This is 31 more than the width. Okay, so what we've done, we made up the system, okay, the linear system, and then we verified SETI's answers by plugging them in both equations. Again, gotta work in both. Okay, so that is our check your understanding on page 397. Okay, we just did that. 397, check your understanding. You can look at the example one as well if you want. That is up to you. All right, I'm gonna erase that. We're gonna go on to check your understanding 2. All right. All right, check your understanding number 2. This is on page 398. Number 2. All right. This says, yes, Lucas? Yep, go ahead. You can go to the bathroom. Yep. Okay, number 2. Create a linear system to model this situation. A school raised $140 by collecting 2,000 cans and glass bottles for recycling. The school received 5 cents for a can and 10 cents for a bottle. Okay, they want us to create a linear system. So what is a linear system? 2 linear equations. So we know from that information we need to get 2 linear equations. Now I'll give you a little tip. The book does do this, but not as much as I would like. Whenever you're doing a linear system or an equation and you're using variables, you should always start with what's called a let statement, okay? Let. And what you're going to be telling people is what your variables stand for, okay? So you can pick whatever variable you want. Oftentimes you'll see a letter that matches kind of what you're describing, but it doesn't matter, okay? That's really up to you. And you're going to just let people know what your variables stand for. So in this case, and if you're ever not sure like what you're trying to find out or what are your variables or what are you even talking about, the last sentence in these is always going to be your clue. So in this one, it said, let's see. Usually there's a question that'll say how many bottles and whatever. This one's not asking me that, but you'll see it saying cans and glass bottles. Okay, you'll see there's 2 different things they're talking about. So let's use C for the number of cans, okay? You can write out the word number or just write number of cans, okay? And the other was glass bottles. So you could use a G for glass bottles, you could use a B. I'm gonna use a B, okay? For number of bottles. Okay, so that's our let statement. Let's let our C mean number of cans and our B mean number of bottles. Now, if I go back to what it said a school raised $140 by collecting 2,000 cans and glass bottles for recycling. Okay, your easiest, oftentimes they'll have a total number of your items, okay? So in this one, they told us it's 2,000, okay? So this is your easiest one to get. Your cans plus your bottles, right, equals 2,000. So this is a pretty easy one. So your first one is going to be C plus B, or B plus C, it does not matter, equals 2,000, okay? So your number of cans plus your number of bottles is 2,000. So cans plus bottles, 2,000. So right now, again, there could be lots of it. It could be 1 can and, 1,999 bottles. It could be 2 cans and, you get the picture. It could be 1,000 and 1,000. We don't know. We need more information. So now, here's a clue for us. It says, the school raised $140. Okay, $140. And it says they got 5 cents for a can and they got 10 cents for a bottle. So, if you knew how many cans you had, which we don't, you could multiply the number of cans by, I think they told us is 5 cents. Yeah, 5 cents. Now you wouldn't write a 5 here because that would mean like $5, but 5 cents would be written like this, okay? And this would be multiplied together, right? So if you had 10 cans at 5 cents, you could multiply that together and you'd be like, oh, 50 cents, right? So I'm going to multiply the 5 cents by the cans, and I'm going to multiply, that's right, 10 cents, okay? You don't need the 0, but you can put it in, by the bottles, okay? So again, if I knew how many bottles and I knew how many cans, I could multiply those out. When I add those numbers together, how much money do I have? Yes, $140. They told us that. So there you have your second linear equation to make up the system. So now we have both parts, and from here, you haven't learned to do this yet, but you could actually solve this. Now in the book, they say in part B, okay, they say the school collected 1,200 cans and 800 bottles. use the linear systems to verify these numbers. Okay, let's go ahead and do that. So remember, just like our last one, if we're going to verify it, we're going to take these numbers they told us, and they told us it was 1,200 cans and 800 bottles. Okay, so let's test that, just like we did the last question, in both equations, and see if the left side equals the right side in both. All right, so let's do the first one. C plus B equals 2,000. Now this is pretty easy to see, isn't it? 1,200 plus 800, does that equal 2,000? Absolutely. Okay, woohoo, so far so good. They could have had this number, okay? Now we need to put it in the second equation, okay? So 0.05 cans plus 0.10 bottles is $140. All right, let's see. And I'm gonna write my cans, 1,200 plus 0.01 bottles, 800 equals $140. Now when you're doing equations, I'll just mention, you don't need to put in dollar signs and cents. You do that at your sentence at the end, okay? So we've got this, 0.5 multiplied out by the 1,200 gives me 60. 10 cents times the 800, we know that would be 80. Is 60 plus 80 140? Woohoo! It is, great. So we have solved it correctly, or they solved it correctly. We verified it. Okay, so the number of cans and bottles was indeed this. Okay, so far you have learned how to make up your system and verify your system. And soon we'll be learning, I don't know about in this unit, but we'll be learning how to solve a system. Okay, so there you have, that is check your understanding number 2 on 398. All right, I'm going to stop there for this video, and I'm going to assign you a few questions. I'll put these up on the classroom as well. For check your understanding number 3, just read through those. I'm not going to go through that. You could read through that, and if you have questions, let me know. Okay, so for today, on page 401, okay, 4, 5, 6, and 7, 8. All right, let's stop there for now. I will be giving you more questions on this, but for today, take a look at these. If you ever want me to go over any of these questions, I'm very happy to do a quick video and put them up. I just don't want to do it for every single question, because if no one's watching them, then why bother? But if you want it, I am happy to do a video. So again, just fire me an email, let me know, and I will do that for you. Or we can talk on the phone, we can do a Zoom chat, we can do a Google Hangouts, whatever you like. All right, that's it for today, folks. Thanks for listening. And remember, math is the only subject that counts. Bye.